A very good morning, everyone. I hope you all are doing absolutely fine. So, we had already started with the P block of 12th standard. The topic which we are going to discuss today is oxo acids of phosphorus, sulfur, and fluorine. Now, this topic is found to be a little challenging. Why challenging? Because I have seen that most of the students have this difficulty in remembering when to use prefixes like hypo, meta, pyro, per, di. So that we are going to see today. So I have this, great method which you just have to follow, and your all doubts will be clear. Like it will directly get into your brains. So without wasting any time, let us jump on to the topic. So let me share the screen. And if you have any doubt, do let me know. Okay. So in the previous lecture, we had already discussed what exactly is parentic acid. Parentic acid will be represented by Pa, and the element in the parentic acid will have oxidation state as plus X. Now I am going to convert this parentic acid into different types of oxo acid like meta, like per, like hypo, like us, like your pyro acids. So we are going to see these conversions one by one. So let us focus on the first conversion. This is your first conversion which we are going to focus. So if we remove one oxygen atom from parentic acid, we will end up with parentous acid. That means your ic part is going to get replaced by us acid. And you will see the change in the oxidation state as well. The element in the parentic acid will have plus X as the oxidation state. And in us acid, you will see that the oxidation state is going to get reduced by 2. That means your final oxidation state will be X minus 2. Now, if I discuss one example, I think you will get a clear picture. So directly let us jump onto the example. Yes. Now for phosphorus, the parentic acid is phosphoric acid. Now let us first find out the oxidation state of phosphorus in your phosphoric acid. Now I had already taught you all how to find out the oxidation state of phosphorus. How to do that? First of all, you should know that what is charge on oxygen atom. We all know that the charge on oxygen atom is minus 2. So we all know that because we can see 4 oxygen atoms, we have to multiply 4 into minus 2. So therefore, we will get minus 8 over here. Then the charge on hydrogen is plus 1. There are 3 hydrogen atoms, so therefore we will multiply plus 1 with 3. So hence we will get plus 3. So minus 8 plus 3 is going to give you minus 5, and minus 5 will be stabilized by plus 5. Hence, the oxidation state of phosphorus in phosphoric acid will be plus 5. Now, this is how we find out the oxidation state of phosphorus in phosphoric acid. Now, if I remove one oxygen atom from this phosphoric acid, we are going to get the formula as H3PO3. And you will see that there is a slight change in the name. Ic part of your phosphoric acid will be replaced by us. So hence the name becomes phosphorus acid. And now if I want to find out the oxidation state of phosphorus in H3PO3, how to do that? Like I taught you all earlier, oxygen has charge of minus 2. So because there are 3 oxygen atoms, 3 into minus 2 is going to give you minus 6. On each hydrogen atom, we have charge of plus 1. So we have 3 hydrogen atoms. So therefore, it becomes plus 3. Minus 6 plus 3 is going to give you minus 3, which will be stabilized with plus 3. So therefore, oxidation state of phosphorus in oxidation state of phosphorus in phosphorus acid is plus 3. So it was plus 5 in phosphoric acid, and now it is plus 3 in phosphorus acid. So basically you can see that the oxidation state has reduced by minus 2. Similarly, let us see one more example to clearly understand that how to do this conversion. So we all know that for sulfur, the parentic acid is your sulfuric acid. So what we will do, first of all, let us find out the oxidation state of sulfur in sulfuric acid, a very simple method to do so. We all know that oxygen पे minus 2 का charge है. So because there are 4 hydrogen atoms, 4 into minus 2 is going to give you minus 8. On each hydrogen atom, we have plus 1 charge. So because there are 2 hydrogen atoms, we will get plus 2. Now minus 8 plus 2 is going to give you minus 6, which will be stabilized by plus 6. Hence oxidation state of sulfur in sulfuric acid will be plus 6. So now we know that the oxidation state of sulfur will be plus 6 in your sulfuric acid. Now what to do? Now just remove one oxygen atom. After removing one oxygen atom, you are going to get H2SO3. And you will see that the last part of sulfuric acid will be replaced by us. So it becomes sulfurous acid. And in this, if I have to find out the oxidation state of sulfur, it is very simple. Each oxygen atom carries a charge of minus 2. So because there are 3 oxygen atoms, 3 into minus 2 is going to give you minus 6. So यहाँ पे हो जाएगा minus 6. On each hydrogen atom, it is plus 1. So because there are 2 hydrogen atoms, you are going to get plus 2. Minus 6 plus 2 will give you minus 4, which will be stabilized by plus 4. So hence you can see that initially in sulfuric acid it was plus 6, but now it has reduced to plus 4. So always you will see that from sulfuric acid to sulfurous acid, there will be reduction of oxidation state by minus 2. So plus 6 has got reduced to plus 4. So this was your one type of oxo acid which we have discussed. Now let us discuss one more type of conversion. So let us see this conversion from us acid to hypo-us acid. Now what to do? Just remove one more oxygen atom from us acid and you're going to end up with hypo-us acid. Like everything will remain same. You just have to add this prefix in the beginning. So you will see that if I'm going to remove this one oxygen atom from us acid, you will end up with hypo-us acid. And you can see that the reduction in the oxidation state will be X minus 4, where X is the oxidation state of element in parentic acid. So let us discuss the example because that will give you a clear picture. So moving ahead, let us see the example. Yes. Now we just saw that your H3PO3 is called as phosphorus acid, in which the oxidation state of phosphorus is plus 3. So now if I remove one oxygen atom from H3PO3, what will happen? We will get H3PO2. And you will see that the name remains as it is, phosphorus acid ही होगा, but we just have to add one prefix in the beginning that will be hypo. So hence you will get hypophosphorus acid. Now in this, if I want to find out the oxidation state of phosphorus, it is a very simple method again. Okay? The charge on each oxygen atom is minus 2. So because we have 2 oxygen atoms, it will give you minus 4. Then we all know that the charge on hydrogen is plus 1. Because there are 3 hydrogen atoms, we will have plus 3. So minus 4 plus 3 is going to give you minus 1, which will be stabilized by plus 1. So hence the oxidation state on phosphorus is plus 1 in case of your hypophosphorus acid. So it is that easy to remember that when to use phosphorus acid, when to say phosphorus acid, and when to say hypophosphorus acid. Now we can see one more type of oxo acid. So let us directly see meta acid. So when to use this prefix meta? When we directly, when we are going to, remove directly one molecule of water. If we directly remove one molecule of water from parentic acid, we will have this meta-ic acid. And you will see that the oxidation state is going to remain same. Here also it is X and here also it is X. So let us see the example. Okay, so I have taken the parentic acid of phosphorus, that is H3PO4. Now what I'll do, I'll directly remove one water molecule from this. So H3PO4 minus H2O actually gives you HPO3. And this will be called as metaphosphoric acid. So you can see that everything remains the same, but prefix which you have to use in front of your phosphoric acid, that is going to be your meta in this case. And also you will see that the oxidation state will remain same. Here it is plus 5, and in HPO3 you will see that again you are going to get plus 5 as the oxidation state. Now let us understand that when to use pyroic acid. So we have example of pyro or diic acid. Now in this case, what you have to do, you have to take 2 moles of parentic acid and remove one water molecule out of it. So we will take 2 moles of parentic acid and remove one water molecule, and you are going to get pyro or diic acid. So, and you can also see that the oxidation state will remain same. If it is plus X over here, you're also going to get plus X over here. So the oxidation state remains same. So directly let us see pyro acid example. Yes, so this is your parentic acid. So what I'm going to do is I'm going to take 2 moles of parentic acid, that is your H3PO4 ka 2 moles, which will give you, now because there are 3 hydrogen atoms and you're going to take 2 moles of it, so hence you will get 6 hydrogen atoms. So H6, phosphorus will also become 2 times. Oxygen, there were 4 oxygen atoms in phosphoric acid, so you just have to multiply it with 2, so therefore you will get OH. So now we have to remove minus H2O from it. After removing minus H2O, you will see that you're going to get H4P2O7, which is called as pyrophosphoric acid, or it can also be called as diphosphoric acid. And here, if you find out the oxidation state, it will remain the same. Like if it is plus 5 over here, so here also you're going to get plus 5. So यहाँ पे भी oxidation state होगा आपका plus 5. Similarly, let us see one more example. Sulfuric acid is the parentic acid for sulfur. So here oxidation state of sulfur is plus 6. What we will do to get pyrosulfuric acid? Take 2 moles of H2SO4 and remove one water molecule from it, and you will end up with di or pyrosulfuric acid. So it is that easy to remember when to use meta, when to use pyro, when to use us, when to use hypo-us. So in the next lecture, we will discuss peric acid. In the next lecture, we will also discuss hypoic, peric or peroxyic acid. So that's all for today.